we are told that a factory has 80 employees. If the number of men is doubled and the women tripled, the staff strength would be 190. Find the initial number of men and women working in the factory. So they said the factory has 80 employees. If the number of men is doubled and the women tripled, the staff strength would be 190. Find the initial number of men and women working in the factory. So you can see from this question, and you can identify that this is a simultaneous equation problem because you're given two conditions. You're given two different equations. You're given two variables also. So the variables in this case are the number of men and women, and you're given their total, two totals. The first total is 80 and the second is 190. So this is a simultaneous equation problem. Okay, so we start by writing an equation for it. So we're going to say let the number of men be m. Oh, I got the m already. Be m. And the number of women be w. So we can then write the first equation as m plus w equal to 80, because we know that initially they have 80 employees as stated in the question, and these employees include the number of men and women. So that means if you add the number of men and women, you're going to get 80. So we can call this equation 1. Then the next part, we are told that if the number of men is doubled, that is 2 times the number of men you had before, and the number of women tripled, that means 3 times the women you had before. So you're going to get the total working staff now is going to be 190. So it's going to equal 190, and this is equation 2. Okay, so you could use any method of solving this since no method is stated that you should use. You could use substitution, elimination, graphical methods, or even Cramer's rule for metrics. So in this case, I'm just going to use substitution method. So I can easily identify that in equation 1, both variables have a coefficient of 1. So I can make any of the variables, I can make either variable the subject of formula from equation 1. And anytime you're making a variable subject of formula from one equation, do not substitute what you get in the same equation, or else you're not going to end up anywhere. Just end up in something like 5 equal to 5, m equal to n, which doesn't make any sense. So what you're going to do, you're going to substitute it into another equation given to you. So in this case, since we're making one of them, I'll say let's make m subject of formula from equation 1. So we're going to make m subject of formula from equation 1 and substitute that value into equation 2. So from equation 1, and make m subject of formula. So if we make m subject of formula from equation 1, we can do that by just simply subtracting w from both sides. So we're going to get m is equal to 80 minus w. So we're going to substitute this. M equal 80 minus w into equation 2. So it simply means anywhere you see m in equation 2, instead of writing m, you write 80 minus w. So we have 2m in equation 2, so we're going to write, and anytime you're substituting any value of something, please put it in a bracket to be safe. So you have 2, so I'm going to put in brackets 80 minus W in place of M. So we have that plus 3W equal 190. Okay. Okay, now the basic reason for making substitution is so that you have only one variable and it becomes easier to solve. Like if you look at this new equation now, you find that we just have W. So W is the only variable. We no longer have M again, so it becomes easier to solve. So what I'm going to do, I'm going to open this bracket. So you have 2 times 80, you're going to get 160, and 2 times W minus W, you have 2 minus 2W. So plus 3W is equal to 190. Okay, so collecting like terms. So for W, the coefficient of W, you have minus 2 and plus 3 equal to, you have 190 here. So if you subtract 160 from both sides, because it's positive 160, the inverse of that is negative 160. So you have 190 minus 160. Okay, so minus 2 plus 3 same as 3 minus 2. So you're going to get 1. 1 times W is W. So you have that W is equal to 190 minus 160. You're going to get 30. So simply means the number of women are 30. So now you've gotten number of women, you can substitute into either of the equation to find the number of men. I think equation 1 is going to be easier since you don't have any coefficient you have to divide by when you finish solving. So I'm just going to substitute W equal 30 into equation 1. So anytime you're doing anything, you must write down your steps. So that's what WAEC requires you to do. They requires you to explain what you're doing, especially when it's theory. If it's objective, you're just doing a rough work, so you don't need to write all that. You just have to be fast. But for your theory, you must explain each step. Otherwise, you're going to lose certain mark because they actually award mark for each thing you do. Okay, so we substitute W into equation 1. So anyway, you see W, you put 30. So in equation 1, we have M plus W equal 80. So I'm just going to do M plus 30 in place of W equal 80. And you also see that M is equal 50 because you have that M, the inverse of 30, positive 30 is minus 30. So I add minus 30 to both sides. So I'm going to have 80 minus 30, which is equal to 50. So the number of men is equal to 50. Okay. So we have M equal 50 and W equal 30. So to be sure this is the answer, you can also do a check. We're just going to do a quick check. So if we already know 30 plus 50 plus 30 is equal 80. 2 times 50, 100. 3 times 30, 90. 100 plus 90 is equals to 190. So the answers are correct because the values of the simultaneous equation or the solution to the simultaneous equation are numbers that when you substitute them for their variables, is going to satisfy the given equations at the same time. So it's just going to be longer than expected because of the explanations or the time used in explaining. So you expect it to actually do it faster. So the B part of number 2, we are asked to solve for x in 25 raised to the power of 3x plus 2 equal to 5 raised to the power of 2x plus 1. Okay, so there we have indexes or indices. So you can identify this as an indices question. And the next thing you're going to notice is that the base on the right and the left hand side have a common factor. So 25 is basically a multiple of 5. So I can write this as, I can write 25 in terms of 5. So I can write it as 5 square. So this is still 25. So what I'm going to have outside the bracket, because 5 squared is representing 25, so I still have 3x plus 2, so equal to 5 raised to the power of 2x plus 1. So if I open the bracket, what I'm going to have is 5. So you have 2 times 3x, which will give you 6x. 2 times 2, which will give you 4. So we have 5 raised to the power of 6x plus 4 is equal to 5x. It's equal to 5 raised to the power of 2x. 2x plus 1. Okay. So now, if I have something like a raised to the power of x equal a raised to the power of 2, you can easily identify that x is equal to 2. For example, let's say you have 3 raised to the power of 2 equal to 3 raised to the power of x. So basically, you know that 3 raised to the power of 2 is 9. That is 3 times 3, 9. And the only thing that is equal 9 is 9. So what are you going to raise 3 to give you 9 is 2, definitely, no other number apart from 2. So it simply means that x must be 2. Since the bases are equal, simply means the power also have to be equal. So the same thing, we're going to apply the same thing here. Since the bases are equal, both 5, so we'll compare the powers. So equate the powers. So we have that 6x plus 4 is equal to 2x plus 1. So we're going to collect like terms. So we have 6x minus 2x is equal to 1 minus 4. Okay, so 6x minus 2x, we're going to have 4x. So 4x is equal to 1 minus 4 is negative 3. So we divide both sides by the coefficient of x. And please note that you have to write this down. Because of time, I'm not actually writing it down, so you have to write this down. So divide both sides by 4, which is the coefficient of x. So you have 4x is equal to minus 3, so it's divide by 4, because it's an equation. Whatever you do to one side, you have to do the same thing to the other side. So 4 into 4, we have 1. 1 times x is still x. And this other side, we have negative 3 over 4. So that means x is simply equal to negative 3 over 4. So that's the answer.